Geometry students, welcome to your video about parallel lines, transversals, and the angle relationships that they create. If you have not watched the video about the streets of New York and the way that their streets create parallel lines and transversals, I want you to go ahead and pause this video and watch that right now. It's under the Explore piece in your lesson template. Okay, and also if you have not read through the vocabulary that's on the first page of your notes, I want you to go ahead and pause the video and read through that vocabulary as well. That's going to be very important for today's lesson. All right, so first off, you should notice this I can statement, which says I can solve for missing angles when two parallel lines are intersected by a transversal. Okay, so I'm really going to begin with example 1, and I'm going to start off by talking about some things that you might see when we're dealing with parallel lines and transversals. So we've got an example here that has line K and we've got line J as well. And the example says, given line J is parallel to line K, find the values of X and Y. So right here, you'll notice that it's got two parallel lines in the statement, and that is an abbreviation in geometry that's saying that is parallel to. So it says given line J is parallel to line K, find the values of X and Y. All right, so some other things that you might see in geometry is you might see that they'll indicate in the sketch or the diagram that these two lines are parallel. And so you might see them indicate that they are parallel by putting an arrow like that on your lines. You also might see that they're parallel, or they might indicate that these two lines are parallel by making a filled in arrow or a triangle on the line. Okay, so they'll fill in that arrow on the line. So it'll kind of look like that. So those are some things that you might see in geometry. And I'm going to set this problem up similarly to a two-column proof. So I'm going to make some statements over here. And I'm going to make some reasons over here. And as I fill this in, you're going to notice kind of why I'm setting it up in this fashion, and this will really get you ready for some proofs whenever you guys get to those, if you have not gotten to those in your geometry class yet. So the first statement that I'm going to make, I typically start off by stating the given information. So I'm just going to repeat what they gave me right here. I'm going to say line J is parallel to line K. And the reason that I'm going to say that is because that was given information. Okay? That information was given to me. Okay? So line J is parallel to line K. All right? And immediately I can start to notice some other angles. Whenever I see a transversal, and we don't have a label for this transversal in our diagram here, but I'm talking about this line right here that is our transversal. Whenever you've got two lines that are cut by a transversal, you should immediately start to recognize the relationships of these angles. So this angle here can be congruent to this angle here because of vertical angles. So I can say that X is equal to 81 degrees. All right. And the reason that I can say that X is equal to 81 degrees is because of vertical angles. Vertical angles. Okay, so I can say that X is equal to 81 degrees because of vertical angles. All right, and one of the vocabulary that you should have learned by reading through the notes that we gave you today, or you should have learned it in your geometry class, is that there are two corresponding angles. If I have line J and line K parallel to each other, then the angle measure for X is going to be congruent to the angle measure for Y because of corresponding angles. So I'm going to actually say that X is congruent. Nope, that's not the right. Congruent to angle Y because of corresponding angles. Okay, and then you can say that y is equal to 81 degrees. And you can call that the transitive property, or you can call that substitution. Whichever one you would like. All right, so geometry students, this is actually a 2-column proof. 2 columns, you got 2 columns here, for alternate exterior angles. This is saying, you can say that y is equal to 81 degrees because of the alternate exterior angles theorem, which is in your notes from today. And this would be a 2-column proof that says that. And you can't use the alternate exterior angles theorem in the proof that you're doing. So there you go. Hopefully that helps you with your example for number 1. So let's move on to number 2. It says, given that line J is parallel to line K, find the values of X and Y. Okay, similarly to number 1, I'm going to create some statements and I'm going to give some reasons to those statements. So I'm going to start by saying that line J is parallel to line K. And the reason that I can say that, well, that was given information. Okay, that information was given to us. And so because of that, on my sketch or my diagram over here, I want to indicate that by creating some parallel line hashes there. And you might even see these done in geometry where there's 2 of them like that. That might indicate that you've got 2 parallel lines. So you may see some stuff like that in geometry. Okay, and so next I can identify that this angle, 98 degrees, plus this angle x would create an angle that would be 180 degrees. And I can say that because of linear pairs. So what I'm going to do is I'm going to write x plus 98 degrees is equal to 180 degrees. And the reason that I can say that is because of linear pairs. Okay? And then let's just go ahead and simplify that. We can use the subtraction property of equality and subtract 98 degrees on both sides of my equation. And then I would end up with x is equal to, that would be 82 degrees. Okay, and I can just say the reason for that is to simplify. Okay, so I have figured out that x is equal to 82 degrees. Well, next I could say, okay, well, because of alternate exterior angles and the alternate exterior angles theorem, I could say that x is congruent to y. The angle measure for x is congruent to the angle measure for y. And I can say that because of alternate exterior angles. Okay? So because of that alternate exterior angles theorem, we can say that y would be equal to 82 degrees. Or we can say that because of the transitive property, or we can say that because of substitution. Okay. All right, so for example 3, given that line J is parallel to line K, write an equation and find the value for x. So we need to fill in the blank here. What is the angle vocabulary that we are discussing here? So the alternate interior angles theorem says that these 2 angles that we're discussing are going to be congruent. And I'll prove that for you for just a second. This angle here that we have said is 80 degrees would be congruent to this angle here because of corresponding angles. And we can also say that this angle here that is 5x minus 15 would be congruent to the angle measure that we're discussing here because of vertical angles. Okay, so those two angles would in fact be congruent. So we can say that 5x minus 15 would be equal to 80 degrees. And so that's what it says when it says write an equation. It just simply wants you to say that 5x minus 15 is equal to 80 degrees. Well, all right, we can go ahead and solve for x and find out what the value of x would be. Let's add. So 5x is equal to 95. And then I can use the division property of equality and divide 5 on both sides of my equation. And I would have x is equal to 19 degrees. For example 4, it says, given that line J is parallel to line K, write an equation and find the value of x. Okay, so let's discuss what the angle vocabulary is in this particular situation. All right, so if we were to take 4x minus 9 and add that to 75 degrees, we would get 180 degrees because these two angles form consecutive interior angles or same side interior angles. Okay, so let's go ahead and set that up. So we would have 75 plus 4x minus 9 is equal to 180. So we have 66 plus 4x is equal to 180. If I subtract 66 on both sides of my equation using the subtraction property of equality, I would get 4x is equal to 114. And then I can use the division property of equality and divide both sides by 4. I would get x is equal to, if I divide 114 by 2, I get 57. If I divide 4 by 2, I get 2. So that's how I can reduce that fraction, or I can say that x is equal to 28.5. So it just kind of depends if your teacher wants you to leave it as a fraction or a decimal. All right, so folks, that concludes the examples for your lesson this week. You do have some independent practice to go through, so please make sure that you do that. And then for those of you who are going to email that to your teacher, we will be looking for that.